So good evening, everyone. And today we're going to look inside some radios. What I'd first like to look inside is this. This is the XHData D219. I've talked about this radio on this channel before. And I want to look inside it because I would like to compare it to the previous XHData I have that's a similar design, which is the XHData D328. There's some significant performance differences between these two, particularly when it comes to overloading on shortwave, and I'm just curious to see whether the chips have changed between them or not. This radio, also unlike this one, has a battery charging circuit and an audio player MP3 player built into it, so it'll be interesting to see just how that's implemented by comparison to this one. And then lastly, I want to have a quick look inside its sort of analog counterpart, which is also a radio I've recently talked about, the Texan R909, just to see what's going on inside this, just to compare it with these radios, which although they look analog, are in fact both digital radios using DSP chips. So my guess is this radio has one chip, this radio has one chip, so this will have an analog radio chip of some sort and associated electronics. This will have associated discrete electronics, This will have, I wouldn't expect a whole lot more than one chip, just whatever the minimum requirement is to create the dial, and I don't know if it would need any amplifiers. I'm curious to see whether there are any transistors in this or not, to be honest, discrete transistors. It will have a resistor ladder to manage the switch and the band switch and all that stuff. It's handled by resistors in these. And this one, I think, over and above whatever's in this radio, is going to have something to handle the battery charging and something to handle the MP3 playback. So that's my guess. Let me get a screwdriver and let's get right to it. Let's do these two first. Let's do this one, then this one, and then this one, just to bring up the rear just by point of comparison. So let me get an appropriate screwdriver. This looks quite easy to take apart. It's got 1, 2, 3, 4 screws and a fifth one hiding under there. And I haven't looked. This is a AA battery radio, and I don't think there are any screws in the battery compartment. I don't see any. So I think maybe if we get those 4 screws out, we should have access to the radio. In just a moment. So, screwdriver obtained. It's going to be too big to get in there. Crashing around, we'll go with this screwdriver set. I think might be better because we want a bit like this one, which will fit into these. Yeah. See, so this is Phillips number 1, which I think is the correct driver. But if I were to go to a smaller one than this, it will be a Phillips 0, which will have a different angle, or the tip will be slightly different. Whereas this one is a Phillips number 1 as opposed to 0. And you can see if you compare the two of them, that you see the angle at the end. This is steeper, and we'll dig into the screws. So this one, most small radios are Phillips number 1. We have stuff stuck in the towel. So yeah, so we'll see if I'm right about one chip. We'll try to figure out what it is and then compare that to the D328. That just fits. way out, have that one all the way out. It's definitely all the way out now. Okay. What have we got? Okay, all 5 screws are out. These are very small self-tappers. Have to be careful reassembling the radio, not to strip those. Okay, so we're not going to get super far into this because we have to be careful of this band here. So let's see if I can show you this. Let me find a flashlight. So the dial on here is handled by this plastic piece that slides in around the top and creates the FM dial at the top here. I'm just looking to make sure that that will show. So the FM dial at the top here, and then the dial pointer below is attached to that. And that's hooked on around the dial switch here. But could we get this board out without? So the ability to get this board out and have a look at the back of it is pretty minimal. But the board is small. It's only in here. There's a crystal. So holding this in my teeth, that won't work because I can't talk. There. Okay, so there's a crystal. There's a wire to, that looks like it's going to the medium wave antenna, which it looks like is right down at the bottom. Yes, I can see it peeking down underneath the speaker here. You might be able to see that down there just below my knuckle here. There's the band switch. There's a capacitor, and there's the switches, and yeah, so there's not much to see on this, and I don't want to take it any farther unless, because I can't remove that board that's held by a screw there. And I don't know what other screws, nothing that I can easily get to. So yeah, so that's it. So so you want to know, why is this radio going for $12, right? Canadian. And the answer is there's nothing to it. We can't see the other side of the board. It's a double-sided board, I think. Yeah, double-sided board. But I wouldn't be surprised if it's a COB, like chip on board kind of deal. I really wish I could see the other side of it, but I actually like this radio and have a purpose for it. So even though I have my questions about this radio, if you've seen my other videos, you'll be aware of that. But yeah, there's really not much to this at all. Okay, so let's see if I can get this back together without wrecking the tuning. The band switch has come out. Here we go. And I'm going to have to get that lined up to get this to work. So let's get this out of here. Okay, this is now Okay, well, you know what? I've got it messed up anyway. Let's take it out. Okay, so that's the front. This is the band switch. Oh, I see. Okay, so I see how that's going to have to go together. They have to get that pin into here. And well, we can figure it out. All right, so let's have a look at this board now that I've gotten this out. So we have a fairly substantial ferrite down here. It looks like we have battery power maybe? Yeah, battery. Here on the top one, it says battery and CN1, channel 1. So let's take these screws out. I'll lift this off. I suspect we're going to have to take this out too, but let's get these two. There's one. There's two. Both antenna connections are soldered in, so we'll have to be careful with those. And we're going to need to take this off here, I think. These are all the same screws, fortunately. This is the back of the battery. This one is not the same. So, this is the back of the battery compartment. And that might give us enough clearance to actually, yeah, that one has a shorter screw on it. It's not shorter, it's just wider. Okay, will that give us enough? Oh, you see, we've got a little bit of hot glue here that's protecting these leads. Not too worried about. Okay, here we go. Well, if I wreck the medium wave performance, it won't make it much worse than it already is. Okay, so let's see if we can reach. There's a little pin there. What do we got here? We've got there we go. All right. So I was wrong. We've got two chips. Okay, let's bring the camera down. Sorry for this. Let's bring the camera down a little bit and see what we've got. This is really pretty fascinating. Okay, so here is the resistor divider for the band switch, right? So there's the band switch under there, and we have different resistor values. What are they doing on the other side of the board? There are 3 layers? Maybe, yeah, it's, you know what? It's a multi-layer board. It's a 4-layer board, and we've got tracks in the middle, so it's hard to see what they're doing. That's probably how they're getting some shielding. They're probably using ground planes on both sides to generate some shielding. Here's the chip. Let's see if I can zoom into that. I can't see what the number is right now. That's zoomed in as far as it goes. Keeping in mind that this is upside down. We'll turn it right side around. Okay, so this chip is, let me find something to write with. I'll move around on my desk. So the D219 chip. Do they mark it? Do they mark that? They don't have the chip marked. I don't see a marking for what it is, but we'll call it, oh, it says U2. U2. So this has got to be U1 here. Yeah, that's U1. Chip U2 and then U1. I always assume when they do that, U stands for unit or something like that because it's integrated unit. I don't know. So let's see what that says. It says S1. Let me get a magnifying glass. I'm trying to read it through the SI. Well, so that tells us SI, so that's the manufacturer essentially. SI 4825A10. 4825A10. Sorry, A10. So that's got to be, it says E3 on it, 21, I don't know, there's got to be a date code underneath, but I don't know how to read it. Sorry, I'm just holding this. You might be able to read it with me through there. Does that work? I think so. I'll look that up later. The other chip, which I'm assuming is going to be an op-amp. No, that's one that's outside. I assume that's the amplifier chip, whether op-amp or something else. Yeah, so I have to tilt that a bit. I don't know if you can see that. D22822M. D2822M. And I don't know what it says below it, but we'll assume that that's the date code on that one. So that's very interesting. So we've got two chips. We've got it cut down to a lot. What else can we see on this board? Do we see any transistors? That could be one. We could have two there where the antenna's coming in. Looks like the antennas are coming in right here. So it looks like there's the other antenna. So let's turn it right side up again. We might be able to find something out if we knew the pin out of this, but we can't see all the tracks, I don't think, because I think there are more layers to this board. Well, maybe not. Maybe not. But these resistors are definitely going through to the other side, I think. I can't see the vias. No, maybe not. And maybe it's only a two-layer board. Let's add a little bit. So the AM antenna looks like it's coming right up to a couple of pins on the medium wave antenna looks like it's coming right up to a couple of pins on this chip. The other antenna is coming over here, and it does look suspiciously like it's got 1, 2, 3 transistors, 4 transistors there, assuming they're all transistors. 1, 2, 3, 4. It's 3 volts, so I don't think it will have a voltage regulator. There's another transistor there. Can we read what any of those are? I can't really. But I mean, it's quite possible it's got some gain over here. It's got a diode on the input from here. I mean, it's possible it's got a voltage regulator, but why would it need it if it's got 3 volts? So, power supply, so I don't know. All right, let's put this one aside and let's have a look at this one. This one I believe, had opened briefly before. So we'll pull out its battery. Hidden. And I will slide this back up. Actually, I'll zoom out. Slide the camera up a little bit, and then you can see what I'm doing, which is taking out this screw here. This looks like it's 1, 2, 3, 4 screws. And the one in the battery compartment is different. The other 3 appear to be the same. Now let's see if we can get this back off. This one, the back comes off. And we've got, I'm not going to try to take this apart more because we can see some of the construction of this. So let me just slide this down so you can see. First, by comparison, this is a much larger board. And we've got 1, 2, 3, 4 chips, a diode on the power supply. One of these has got to be the audio out, probably this one because there's the audio out. This is the band switch under here, same thing. You've got a diode, a resistor ladder for that. We've got, I'll read the chip number off for you. So on the D328, that was U4, according to this. And let's see if I can read it. I won't try to read it for you guys, I don't think. Well, I will try to read it for you. So it's SI. So, same manufacturer. SI 4825A10. 4825A10. So it's the same chip, right? I'm going to guess that we've got a charging chip and a whatever, because this is connected to the buttons here, right? You can see they're connected through a single pin to these buttons here, different resistor values to get the results. That's connected to the card reader. So this is doing whatever is required to do the MP3 playback. This is, I'm guessing that's the charging controller chip. I have taken this apart before, and I do have a video about that. We can see the similarly sized ferrite along the bottom of this. There's a diode on the input, and I just want to read this chip to see if it's the same one. LTK, no, it's not. Maybe this one says LTK, and what is that? That is U3 LTK. Again, sorry for sticking this. LTK 8002D. 8002D. U1 is not what I thought it was. ATML 902. So there we go. ATML 902. And this one is, I've got to turn it over. That was going to be U2. A820CM. A820CM. 3MOU. 3MOU. And then 182. I don't, some of that's got to be date code. So I think that makes this a microcontroller. What's handling charging? Are they leaving the electronics in this battery to handle the charging? Mostly? Don't know. Anyway, I suspect that's the amplifier. This is the same chip as in this radio. But I do want you to look at just how much more complex this board is than that board. This radio is $5 more, although they may have simplified it. It may not be the same as this version from 2 years ago. Very interesting. Speakers are different too. This is a fairly chunky speaker. This thing produces a fair amount of bass considering what it is. All right, well, that's a look at those two. And let's just very quickly take a look inside the analog radio and bring that up again. Remove batteries. And we'll see this one, if I remember, there's just one screw, which is, okay, that's incredibly tight. It does not, all right. So I think I'm not getting into this radio because I really like this radio and don't want to bust it, but that's incredibly tight, as in I'm going to break something if I try to open it. I'm not going to. So I'll put this one back together. I'm going to look up these chips that I found, and that's a bit disappointing. I was quite looking forward to getting into this radio, but I absolutely don't want to bust it. I don't really want to bust the other two either, but this one I'm weirdly attached to. So, well, let's put these back together and then we'll look up the chips and see what they say. This one's easy to put back together. We just drop that back in. We put our, well, that one didn't even come out, these two. And there's a slightly shorter one that goes in behind the battery. There. I'll tighten that back up. Here, let me slide that up a little bit. Not sure how well I'm doing with framing on all of this, but it is interesting that I did not see an obvious charge control chip in this, which is maybe disappointing. Maybe it's hiding somewhere else. Could be on the other side of the board. All right, now we just slide the battery back in. 3 contacts on these, and put that on. Make sure that that works. All right. Yeah, so there's some shortwave reception. So, works. Okay, now this one is going to be a little bit more complicated. And I have some trepidation about getting this back together. So, this is going to go in here, like this. And we need to make sure we keep that out. So we've got to handle getting this under, oops, let's not lose that. Which way around was it? Doesn't matter. That way, I think. So we got to get all these things lined up at once, which is probably easy if you've done it 20 times, but not so easy if you're doing it for the first time. There we go. I think we're okay. We got that pin in. Okay, this was the battery connection here. So we'll just put that in since we're there. We've got that pin in, so we have 2 screws, one here and one there. And there we go. Put them out over there for now. We'll put that's why I'll do this one first. So, 1 screw holding the board in place. And the second one that I have. That will help. We'll try these. There is a magnet in the screwdriver, but it's not very strong. So, okay, there we go. So now we need to get this. This is holding in ferrite, which is what's causing a little bit of trouble. Getting this in here. There we go, but I think we've got it. There's the ferrite down there. I would assume the ferrite in the D328 looks similar, but I don't have any way of knowing since it's on the other side of the board, and I'm not going to chance that. Oh, these screws were different. This one went over here. So I'll put that in there, and I'll do this one. And that should handle the back of the battery box. I don't like this at all. Let's get this out because I've got these wires routed incorrectly. At the moment they're routed through the battery box as opposed to side of it. You can see where I put some stress on the antenna wire. I don't think that's going to be any problem. I worry a bit more about the... This would be a lot easier if I just pulled it out against the hot glue, but there we go. So these need to be routed over here like that, so they don't run through the battery compartment. There we go. This is the one I'm really concerned about. The FM antenna wire, or the shortwave antenna wire, can be fixed easily enough, no problem. But these little fine ones from the medium wave antenna, I mean, again, medium wave is fairly terrible in this radio for North American usage, but all right, so there we go. So that's in shape. So we can see how they've got the little marker. I'll show it to you on this radio because it undoubtedly works the same. This little marker that shows what band you're on. It's just a little white dot on the same plastic piece. Very simple, works great. A very good design. So that goes there, and then this runs along here. Okay. So now the question is going to be making the dial work. The dial works by this little plastic thing coming in and out. So we'll pull it all the way over to give us as much space to work with as possible. I'll put in the speaker. Otherwise I'll forget to do that. So this then goes in here. And if we wind that all the way over to this side, I think it'll just go in. Shouldn't worry about that a little bit more. So the problem I have here is that I've got it. Look at that. Bandwidth switch is working. That's working. All right, let's get the screws in before I make it any worse. I've lost the serial number from the bottom. Oh, I'll stick it in down here. Don't really care about that. So, one in the center. So there's no way of adjusting the dial. Mine's off fairly significantly, but consistently across all bands. There's no way of adjusting that here. It would have to be done in software. I didn't see any variable resistor or anything, potentiometer that you could use to solve that problem. And I'm getting a lot of views of my hand doing things. So I will say that this is an interesting but flawed radio. I think it's a fun radio to play with if you're an enthusiast, and it doesn't cost any money to speak of, right? It's, less than $20 Canadian to bring it into the country. If you're amused, want to play with it, then you absolutely should buy one. I think it's got some issues, mainly related to its medium wave performance and its shortwave performance in urban environments that make it maybe not the best choice as someone's first radio, and the medium wave performance makes it a bit questionable as an emergency radio. But if you live in the country, then I think maybe those don't apply. All right, let's see if this is working. So I got FM. Let's try medium wave. Yeah, that's working too. Well, let's pop it up to band 2 on here. There's plenty of stuff. On this radio, putting up the antenna doesn't necessarily, but that is, now I would say it is pretty impressive in some ways. That's Radio Japan from Issoudun, France. It's being interfered with by all the electronics right here at the desk, but that's Radio Japan from France being rebroadcast into Canada here tonight. Okay, so we have these two radios back together. We unfortunately didn't get a chance to take this one apart because a 200-pound gorilla put that screw in, or a 200-pound robot, whatever, put that screw in, and I'm not going to chance taking it out. It might be that the whole thing clips together in that, but I don't think so. I think this is a design used in some older radios where there's like a single screw and then clips all around the outside. And I don't really want to chance it because I don't want to break it. But these both went back together just fine. I'm going to look up those chip numbers and come back to you. Okay, so the first one, this SI 4825A10, is a Silicon Labs, which I did know from the SI at the beginning. I don't know much about chips, but that one I knew because I know it's used at a lot of radios. It's described as broadcast mechanical tuning, AM, FM, shortwave radio receiver. So in other words, it's a purpose-built chip for this purpose. Its support is world band FM support, 62 to 109 megahertz. So we see 64 to 109 megahertz, 64 to 109. These radios have this dual FM band, which is great because you have North America, and then if you're in Asia where you could use this lower end of the FM dial, that's separate. So that's a nice feature of these radios. It says worldwide AM band support, 504 to 1750. So where they're not doing that, they've got 522 to 1620 marked on the dial anyway. Shortwave band support 2.3 to 28.5 megahertz. And they're obviously not covering all of that, but they're possibly because there are interference concerns on the lower bands, maybe, I don't know. I should say the dials on these two are, if they're not exactly the same, yeah, they're exactly the same. Yeah, they're exactly the same on these two radios. We got no manual alignment necessary, mono audio output, so no possibility of stereo FM, selectable support AM, FM, shortwave, regional bands, all the usual stuff. Let's just see. I'm just going to click on the AM receiver. One of the bands is universal AM band AM4 520 to 1730 kilohertz, supporting both 4 kilohertz and 10 kilohertz channel spacing for all regional AM standards of the word. Similar to the FM receiver, the SI 4825A10 optimizes sensitivity and rejection of strong interferers, allowing better reception of weak stations. It's not clear to me how it switches between the two of those. You probably have to switch. So somewhere in here there will be a band chart. That's the way these chips tend to work. I haven't found it. Anyway, one of the concerns with this radio is that its medium wave performance is poor in North America, and it doesn't seem to be switching, or it doesn't seem to have the ability to go to 10 megahertz, 10 kilohertz channel spacing in the North American environment. And in another video, which I guess I'll link below, I demonstrated that, how that works, and I compared it to a Texan PL330, which can be shifted between 9 and 10 kilohertz spacing and replicated the same problem that you see on these radios. So that's what the problem is. It may be that they have the chip implemented incorrectly. That's interesting. Okay, so let's look up the rest of the chips and see what they do. So as I surmised, the second chip on the, this is the D219 here, is a power amplifier. That's a Silicor dual power amplifier. It's intended for use as dual audio power amplifier in portable cassette tape players and radios. Runs on a supply voltage down to 1.8 volts. Power output, it's got 2 channels. I don't know if they're only using 1 channel or if they're running across both of them. It looks like it can manage 1 watt. At 9 volts, so at 3 volts it's managing 100. Sorry, that's at 6 VCC, 6 volts. Yeah, so at 9 volts it can manage 1 watt. At 6 volts it can manage 0.65 watts, and at 4.5 volts into 4 ohms. Some of these, they're switching between 4 ohms and 8 ohms, and 9 ohms it looks like it likes 8 ohms. It wants 0.32, and it's at and at 3 volts it's managing 110 milliwatts into 4 ohms, which is what it's going to be doing probably. Well, actually it might be 4.5 volts, so that might actually explain, assuming that this one's using a similar chip, that might explain its slightly better sound output, because it's got a 3.7 volt battery. That might give it a little more oomph. Who knows? So that's what that is, just a standard power amplifier chip. So let's look up the Atmel and then this one on the D328, see if we can figure out what they all are. Okay, as I thought, U3 is the audio amplifier. The data sheet I have is in Chinese, so I can't read it, and I don't really feel like taking it through Google right now to try to figure it out. But it's probably very similar to this chip here that's used on that. So we have the basic requirements, right, are these two. Okay, we'll look up the next two. So this Atmel 902 chip, which I thought might be a microprocessor because of the name, looks like it's a serial EEPROM. So that's the program for whatever this one is, and that looks like an Atmel name too. So let's see what that is. So with my limited Google experience and chip skills, I haven't been able to figure out what this is. But if I'm right and this is a serial EEPROM, this has to be a microcontroller of some sort. So that's got to be a microcontroller. That's got the program for it. And then we've got the radio parts here. And the microcontroller has to be switching this audio amplifier chip. Its input signal has to be switched between this chip going in and the output of this microcontroller. That's the only way that could be done. So I hope that was interesting. Pull the radios in once again. We can certainly understand why this radio is so inexpensive, because there's really not much to it. 2 chips and a cleverly designed little circuit board. This radio has a little more in it, but I mean, we all know that it's not a whole lot more complex. I bet a lot of the difference in cost, you know, apart from maybe $1 more in parts, comes down to the cost of the battery that's included when you buy it, as opposed to this one where you have to provide your own cells. Unfortunately, as I said, I wasn't able to open this one, but we can look in a different analog radio at some point or another. I hope that was interesting. I don't know that, at least for me, whose knowledge is fairly limited about these things, I've learned that much. But they do have the same chip, and I suppose maybe I could stop and look at some of the pictures of the circuit boards that I've taken with these two, and maybe they'll show me something interesting in the future, but that's not going to be part of this radio. Thanks again. Have a good evening.